All right, so here we go with the real 4.8. All right, so let's jump into it though. There we go. All right, so in this case we're trying to find ECD, so that's this angle here. So let's just start with what we know. We have an isosceles triangle, which because it's marked, the two sides are congruent. So if this is 31, right, then this, because the two angles opposite are congruent sides, would both be 31 and 31. So together, that's 62. So we do 180 minus 62 is 118, is this angle up here. But that's also this angle here, right? So ECD is 118. All right. Angle K, we're sort of doing it the same way here a little bit. We recognize, hey, look, it's an isosceles triangle. So these angles are congruent. Our vertex angle would be this angle L. Our base angles would be J and K. They're congruent. So in this case, I'm basically doing 180 minus 82 gives me sort of 98 here. But I got to split it into two equal angles because they're equal. I know that together they add to 98. So, but I got to split it. And so we basically just end up with 49 for each degrees. So both of them are 49. All right. Box this one too for fun. All right. So next up, we're sort of doing the same thing here. We just recognize, oh, look, Z is our vertex angle, X and Y are base angles. They're opposite. They're opposite of the congruent sides. So we set them equal to each other, right? They're base angles, so they're going to be congruent to each other. Just like I know that the two sides are congruent, so I can set those values equal to each other if I had them. In this case, I'm doing with the angles opposite of them, so they're equal. So we get 2t equals 16, so t equals 8, which is not what we're trying to find. We're trying to find angle x, so I go ahead and plug it back in. We get 8 times 5 is 40, minus 13 is 27 degrees. So let's put it up here, equals 27 degrees. All right, angle A. In this case, we have 4x for the vertex angle. 2x is one of the base angles. We know the other base angle is going to be 2x as well. And then we have three angles in the triangle, so we know that those add up to 180. Plus there equals 180. So we end up with sort of 8x equals 180 there. And so we end up with, I believe it's 22.5. And so we're trying to find the measure of angle A. We plug it back in and we get 90. Is that right? Or is it 25? I don't know what this equals. Actually, let's do this. I should have been more confident. Maybe I shouldn't have. I don't know. Let's see. Yeah, 22.5 and then times 4 is 90. Yeah. All right. So I actually was totally right the whole time. All right. So when we plug it back in, right, because 4 times 22.5 is just 90. So that's what angle A is, because I just plugged it back in here. So angle A is 90. Just want to make sure I was right for you guys. All right. In this case, we're dealing with an equilateral triangle, right? All the sides are equal, which means all the angles are equal. But not only are all the sides equal, and all the angles are equal, but if all the angles are equal, they have to be 60, right? So in this case, we know that one of them is, can I see that? One of them is 12y, all right? They're all 60, 60, 60, 60, but 12y and 60 are the same thing, right? So it's like, hey, yeah, it's going to be 60 here. So 12y equals 60. Oops, 60, not 160. So y just equals 12 there. 5, sorry. Let's switch to red while let's switch to blue while we're at it. So 5. All right. So y is 5. That's what we're trying to find in this case. So check, y equals 5. All right. So now we're kind of doing the same thing. Hey, it's equilateral. Therefore, they're all 60. So if they're all 60, we can say, oh, well, this is also 10x plus 20. So that's going to equal 60. So we get 10x equals 40. So we get x equals 4. We're trying to find x. We did. X is 4. Awesome. All right. Assuming I'm good there. All right. Okay. So here we go. These are good questions. We're trying to find angle E, which is way down here, but I'm only given angle A. So in this case, we recognize angle A is the vertex angle of this isosceles triangle. I'm going to go ahead and just mark these congruent here, so that that's fine. Because they're the base angle. So if this is 96, we're going to do 180 minus 96, right? And we get 84. And so if we take 84 and we split it in half, each of these angles are just going to be 42. So we get 42. In fact, it's a blue 42. in blue. All right, so that's 42. Sounds good. So we know that this right here is actually going to be 42 as well because of vertical angles. And so we kind of have to do the same thing now again, because the congruent angles are going to be, these are the base angles of this isosceles triangle. These are the same. The sides opposite, sorry, the angles opposite the congruent sides are equal. So we get 180 minus the 42, right? And so we get 138. We split it two ways and we get 69. So each angle here is 69, including angle E. So again, start with what you know, walk to what you're missing. Same kind of thing here. We're looking at this big triangle SRU, this big one here. So we know this is 57 as well, because these are opposite. These are our base angles of this whole triangle. And then we said this is 57, this is 57, that's 114. So 114 would be 66, right? So this whole thing, this whole angle up here is 66. I should make it both. So the whole thing is 66. But what happens is it's showing me that this angle and this angle are congruent. So what we do is basically take 66, and because this angle is sort of bisected by RT here, I just split it. So each of these smaller angles are 33 degrees, right? So it's sort of like both this angle and this angle, they're both 33. And true is TRU equals 33 degrees. True. All right. So tell whether each statement is sometimes, always, or never true. All right, so equilateral triangle is an isosceles triangle. That is always true, right? So that's always true because sort of by definition, equilateral, has, if it's equilateral, we know that at least two sides are congruent, which meets the definition of isosceles. This says the vertex angle of an isosceles triangle is congruent to the base. This is actually sometimes. Might as well just write the whole word out. So we do always. Always. All right, so we got sometimes. And then sometimes that works because most of the time it doesn't have to be, right? If I sketch this out, I'm thinking, okay, well, this could be, 70 and 70, and this would be 40. So the vertex angle isn't equal, right? But in the case of an equilateral triangle, they're all 60. So the vertex angle up here would be the same as the base angles. So the only time that it's true is if it's an equilateral triangle, but that is sometimes. It says an isosceles triangle is a right triangle. Well, you can have, of course, isosceles triangles that, aren't a right triangle, right? But you can also have isosceles, this looks the same. You can also have isosceles triangle that are right? So we can just draw two examples because they both look about right angles. But so you can have isosceles and right. That definitely works. And we know a lot of stuff about them. Vertex angle is 90. Each of the base angles has to be 45, etc. All right, an equilateral triangle and an obtuse triangle are congruent. This is going to be a big, this was also sometimes. Because it doesn't have to be. So if you can think of one situation where it is and one situation where it's not, that's sometimes. This one's a big fat never, though. The whole point is if it's equilateral, right? We know that it's equal angular as well. That means all the angles are 60, 60, and 60, which means that leaves no room for any of those being obtuse, right? So they can't be obtuse, right? They just can't be. So that means an equilateral triangle can never be obtuse. So that's why it's never. Okay, let's do these. We know that these lines are parallel. They're not going to mark it parallel for no reason. So I'd say, all right, let's look here. I could mark some angles congruent. Angle 1 and this angle are alternate interior angles, so they're congruent. I could figure out that angle is because this is an isosceles triangle. So our base angles are, in other words, our angles opposite our congruent sides are also going to be congruent. So that's 58. So is that. If that's 58, so is that, right? If I can find out what angle 2 is as well, which is fine. What I would probably look for here is recognize that if this is 58, this is also 58 right there. Again, those are alternate interior angles, right? That stuff's not going away. We got to know that. And again, a couple ways I can go. Either I can add these 58s and subtract from 180 because they're a triangle, or add these 58s and subtract from 180 because they're a straight angle. Sort of like take your pick in this case. So either way, that's 116 if I add them up. So that's 64 is going to be angle 2. Okay, and then angle 3, it's just 180 minus 58 here. So we could just say 122 for angle 3. So those are them. There's angle 158. All right, cool. All right, and 29 here, we're basically saying if this is 74, right, I can say, and these are the base angles, so I'll go ahead and mark those because, again, angles, these sides are congruent, so the angles opposite them are congruent. So what I'd say is if I take 180, because those are all part of the same triangle, and I subtract 74, right, I get 106. So if I get 106 for these two angles together, I split them in half to get each one individually, so I get 53. So 53 degrees here and 53 degrees here. So it looks like angle 3 is good, 53. And then over here, we can subtract from 180, right? So we can get 127 right here when I subtract from 180. So that's angle 1. Then we're thinking, well, these angles also have to be congruent. So 2 in this other one, because these sides are marked as congruent. So the angles opposite them are going to be congruent. What happened? Oh, found it. It came back. All right. So we just do 180 minus 127. Right, and we get 53, and then split it in half, so we get 26.5. So 26.5 is perfectly fine. Each one of those would be fine, including angle 2. So 26.5 is angle 2, 127 we have for angle 1, and 53 for angle 3. All right, we did these exact ones, right? These are up top. These are classwork ones, so we didn't have to do them again. But again, the main thing here is that you definitely know how to do them 100%, and we did them in class. But I think I might have actually changed these values so that the next class they would be different, but you guys had the same ones. Essentially, again, just to walk through them, is that this says the legs of an isosceles triangle have these lengths, and then it gives me the base as well. Well, again, if I sketch this out, you'd see that the legs of an isosceles triangle are always congruent. So we'd set these two equal to each other, these two expressions, find x, plug x back in to find anything we need. All right, in this case, there's one base angle of an isosceles triangle measures 54. Find the measure of the vertex angle. Well, if a base angle is 54, that means the other base angle is 54. So we have 108 between the two of them. And so 72 has to be the vertex angle. And again, I'm just walking through sort of how we do them. I would definitely sketch these out if I were doing them. I would not just do them verbally like I'm doing. So keep that in mind. But because we did them on your sheet, we're good. In this case, I draw this triangle. I mark two sides congruent that they give me. And then from there, I would know the vertex angle or not. So in this case, the vertex angle is what it gives me. And so I'm trying to find one of the other angles. So I do the 180 minus the vertex angle, split it in half because the base angles are congruent. It says find the measure of the vertex angle of an isosceles right triangle. In an isosceles right triangle, the vertex angle is always the right angle. Ooh, that's not great because those are congruent here. So the legs, the angle between the legs here is going to be our right angle. So we have it. It's always going to be. So each of these angles, the base angles, right, that are congruent will be 45. And that's going to be 90. Adds up to 180. Makes sense. All right. So ABC is an equilateral triangle. Find angle A. Well, all the angles, angle A, angle B, angle C, all have to be 60. This is a super straightforward one. We should definitely sort of know that as if it's a fact. It is. All right. So let's do this first one here. All right. So we start with what we were given. We know this is the vertex angle of an isosceles triangle. So we know that these other two angles are congruent. Now, do I really need these in this case? Sorry, these are not. We'll see if I need them. I'm going to go the other way. I'm going to say this is 28 degrees, and it's actually part of, it's complementary with this angle, right? So really, I'm just trying to add them to, get 62, and because I add them together to get 90. I know they're complementary because here's a right angle right there. So then in this case, I have an isosceles triangle that says that the angle is opposite, the congruent sides are congruent. So that's 62. So is that. Together we have 124. So if I get 56 to get 180, so I know that 56 is going to be x. Right. All right. So we, in this case, let's see, we start with what we're given. We know that has to be 60. We know that these have to be the same because of where these angles are marked. Now, in this case, you can also do exterior angles. In other words, these two are the same, and they have to, because these are remote interior angles, right? So 120 is an exterior angle, which means these two angles have to add up to it, and they're the same, which means they also have to be 60. So yeah, because you know 60, 60, 60, you actually know that they're all congruent. But in this case, if this is 60, this is 60, and if these are congruent, then that has to be 60 there, which means x has to be 60. There's a whole lot of 60s happening, two equilateral triangles in there. All right, so let's look at this one. Basically, we're trying to find x here, right? Because it's telling me that 2 is 4x minus 2. If I can find out what it is, then I can just make an equation and solve. That's going to be my goal here. So if I do that, I get 68 here. Base angles are congruent. Again, look opposite of your congruent symbols to mark the sides, right? If you have two congruent sides in the same triangle, then you have two congruent angles as well. All right, so we have 68 right there. So we get a total of 136, right? Which means that we have 44 is this angle right here. So if this is 44 and this whole thing's 90, this has to be 46. Now, we don't have to go any further. I could find these if I wanted to, but this is 46, which means I know that angle 2 is 46 and it's 4x minus 2. So if I just set it equal to 46, right, I can then solve. So 4x equals 48, x equals 12, right? So once you find the angle, then you have something to set it equal to. It's like I can just almost replace it with that once I know what the measure of that angle is. Same thing goes here, right? We're going to go 146, so we're going to go 34, right? These are base angles, so we get 34 here. I could find that. I don't need to, but I could find it if I wanted to. So this is 34, so this is 34, right? So this is 146. So angle 2 equals 146, so I'm going to bring it on up here, and I'll just put it on this side for simplicity. So we get 13x equals 149 here. Again, I don't know what that is, so let's do a little calculation. 149 divided by 13 gives me that. Right, I put 14. I don't know if I did it right. No, I did it. Oh, it's subtraction. Sorry, it's going to be 143 divided by 13. Sorry, which is 11. Mistakes, they happen, but that is it, right? So that's it with this worksheet here. So if I just finish this one up, right, it was 143, so x equals 11, right, which is what I was trying to find. And now that is for reals done. All right, for reals. What are we doing here, people? All right, I don't know what's happening. So we're gonna go ahead and erase it and write it one more time. Okay, sounds good. No, I think the video is done. You can stop it now if you want. I'm going to fix this one, but x is 11. Cool. Where are we? There we are. X equals 11. Nailed it. All right, cool. See ya.